This MP3 file is malware. And it is literally a .mp3 file. It's a sound file, it's an audio file, it is actually a song. If I'm taking a look at the details here, apparently Gnosis hardware from Professor Click, produced and available on Jamendo.com, which is a real thing apparently. Jamendo.com lets you stream music. And this is a totally playable audio file. It's a song, right? Gnosis hardware from Professor Click. I can play it for you, and that's that. But here's the thing. This was sent to me in an email, and thank you so much. Please do keep sending me malware. This was a click fix or CAPTCHA scam, Windows key plus R scam, but it's an audio file. Individual says, hey, I'll be quick. Came across a WinR dialog scam, but it's an audio file. Here's the copied text, and they include the link here, defanged, redacted to not include the full schema, but it says here, it basically MSHTAs this file, being the MP3 file. So if this MP3 file were invoked with the mshta.exe file, built-in, native, always installed on Windows operating systems, well, then it'll do something entirely different. It's how you open this file with a different program. Not to say the MP3 file or the song is malware, but it contains malware and it'll execute with MSHTA. And MSHTA is the Microsoft HTML application. If I hop over to see Windows System 32, we can find it here, mshta.exe, Microsoft HTML application host. Now this, by default, will render and display HTML, hypertext markup language, the structure language of the internet and web pages. But invoked locally on a Windows computer, it'll evaluate, run, and execute other scripting languages, like VBScript or JScript, a dialect of JavaScript, but client-side on Windows. Now, we've covered this in many videos before, but MSHTA is interesting because it is one of the few programs that allows you to work with files that are polyglot files. So a file that is one type of file, like an MP3 file, but another type of file at the same time. They're both totally valid. MSHTA will skip over and ignore everything that isn't valid code that it's able to work with. So inside of this MP3 file is malicious code that we could explore. It is going to be either HTML or JScript or VBScript, right? So it's plain text. It's a scripting language that we could read and make sense of. I'll drag this into Sublime Text, my text editor of choice, but being a binary file like .mp3, we're not going to be able to make much sense out of this. It's just the hexadecimal representation of the raw bytes. But being plain text, we could carve this out with super simple but overpowered tool, strings. So let me open up a Windows terminal here, and I'll full screen this with F11 so we can see it a little bit better, and I'll hop over to that directory. I do have it in my malware directory for MP3, and I'm actually going to use the strings that's included in the sysinternal suite. I do have that downloaded inside of my Windows 11 virtual machine here. It will need to accept the EULA or that end user license agreement, but with that, we can just give it the file, and then it'll carve out all the plain text strings that it can parse. Super simple. I don't think I need to particularly explain the usage of strings to you, but because it'll dump so much stuff, it is probably worth noting one of the other arguments or parameters we could provide. I'll hit Control-C to stop that, but if I were to actually supply another argument, like -n, that'll specify the number of characters that it will use to consider, okay, this is a string. By default, I think the minimum is 4, but if we tighten that up to 8, well, okay, now you can see a longer length there and some sketchy stuff. Let's adjust that again. How about 12? Okay, now you can see all this present. It's obviously going to be a very long line. So what if we set that to 100? And then we might be able to carve out just that blob. Sorry, I know it's got a little bit of a matrix look to it, but let me redirect that and actually put it into, I guess, stage 1 HTA, right? It's going to be hypertext or HTML with some scripts included. So let me try to open that up with our stage 1. I'm using Sublime Text again, but this included the little banner from strings. And then at the very end, okay, we do see another long one, you lame, probably a leftover artifact from the MP3 file that just happened to be longer than 100 characters long. So this is the malware. Let me save this, and if I try to set the syntax to HTML, well, because these are all on one ginormously long line, about the very bottom you might be able to see 102,719 characters selected, so that's quite a big thing over on the minimap sidebar here. What we could do to break this up is knowing, okay, what are they using as sort of a delimiter for different commands or instructions they might use? Normally we do this with semicolons, but with this being HTML and trying to include different script segments in Visual Basic Script or JScript, I believe it'll default to JScript here, you can see a lot of frequent ending script tags, right? If I highlight these with Control F, they are all over the place. So we might be able to use that ending script tag as our delimiter, where if we were to replace all of them with some new line characters, and I'll make sure regular expressions are on so that we'll parse and process properly with our new lines, I'll hit replace all, and now we've got our syntax highlighting. And this is much easier to read. But a lot of this code looks like nonsense. In fact, it doesn't even look like code. But if we get back to the very top, this is where they do something that I think is kind of neat. Hey, real quick, before we dive too deep into the code and fall down the rabbit hole, please do let me take just a couple moments to tell you about the sponsor of today's video, Vanta. Whether you're starting or scaling your company's security program, demonstrating top-notch security practices and establishing trust is more important than ever. Vanta automates compliance for SOC 2, ISO 27001, HIPAA, and more, saving you time and money, while helping you build customer trust. You can streamline security reviews by automating questionnaires and demonstrating your security posture with a customer-facing Trust Center, all powered by Vanta AI. Over 7,000 global companies like Atlassian, Flow Health, and Quora use Vanta to manage risk and prove security in real time. And you get a special offer of $1,000 off Vanta with my link below in the video description, jh.live/Vanta for $1,000 off. That's a discount just for our community, jh.live/Vanta for $1,000 off. Huge thanks to Vanta for sponsoring this video. But if we get back to the very top, this is where they do something that I think is pretty neat. You can see the very first script or line of code that's ran, they move the window.move to, with an X and Y position here, X being, okay, the very top, just 1, but 99999 means, okay, we're gonna move that way off screen, so the window, default graphical user interface for an HTA file, is not actually going to be seen. It hides it from the user. And then, this is the neatest thing, window.onError is set equal to a function that will return true. Totally anonymous function, doesn't have a name, doesn't need a name, but what that means is it's setting an error handler. So if any errors happen, like if there's any bad syntax errors for any of the other lines of code that follow in other script tags, since it'll keep that global context with browser-based scripting languages. All of this code that does not make sense, that is not real or valid code, is going to be totally skipped over because it's set that error handler to completely ignore or return true, you're fine, no big deal, for any and all errors. This is pretty slick. That means that all of this code does not matter. Dare I even call it code, because clearly it's not. Hard part is, though, now we're looking for a needle in a haystack. Do we know which of these many lines, let me go to the end, okay, about 1,000 of them, what of these even matter? Window.close at the very end, okay, finishing it up, but all the stuff in between, I don't want to have to sift through 1,000 of these. Thankfully, we can use the mini-map and just sort of do some broad strokes here to be able to see, okay, does anything stick out? And you might have already seen it. Yeah, giant chunk of data there. That's probably going to be used. If we're looking at the scripts all above and below that really do anything previously or after, none of them seem to matter. But this one probably does. The line is so long that we don't even have syntax highlighting for that script tag, but look, it's setting a variable, IJOOZM, to this giant blob. So what we can do next is just simply look for the usage of that variable. I'll Control F for that. Okay. Now line 854, when it was defined at 334, 854 actually starts to do something with it, and it uses the eval statement, which means execute more code. It'll treat whatever string or data that's passed to it as syntax and more code to run. That is kind of a little detonator. That's another stage of malware that we could extract and unravel. What they do is they take that IJOOZM variable and replace, with some regular expressions here, only noting dot meaning match any character, but the parentheses noting to group or cluster one match or result, it'll only take the first two characters out of a set of 3, and then it ends up parsing it as an integer in base 16. Hexadecimal, right? Now, we probably saw that pattern when we were looking at the variable. Despite it being a giant blob of nonsense, only the first two characters match what would be hexadecimal syntax, right? 7-6, ignore the Z, 6-1, ignore the X, 7-2, ignore the F, etc., etc. So what we could do is actually grab this line and then create our own little script to evaluate it. We'll actually use the syntax and the code itself to determine what the value inside of the eval function actually is. But we'll be sure to sort of defuse this, right? We won't actually want to call eval. If I set this to JavaScript as just the example, let me turn word wrap back on. Let's be sure to remove the eval function and its leftover parentheses closing there. Since this is JScript, similar enough to JavaScript, we could let this run and evaluate in two different ways. We could do it even in our browser. Like if I were to open up Brave, there's nothing wrong with that. You could use any of them. I can hit F12 to open the developer tools and then get into a console where I could just execute any code that I wanted to. JavaScript in this case, but the syntax is so similar that it won't make much of a difference. Or we could do something like running it with Node.js locally, just running JavaScript. Or honestly, back in Sublime Text, we could just save this with a stage2.js extension, being JScript in this case. Back over in Windows Explorer, you can see stage2.js would run naturally with like wscript.exe or cscript.exe, running it from the command line on Windows. Just because it's kind of neat, I will actually go run this in a web browser, and if I try to paste this, it will whine and yell at you. You do need to make sure that you hit allow pasting, and then with that, I can hit Control-V, enter all this, and it'll evaluate now what the second stage is actually going to end up being, while it would have been passed to eval. Let me right-click, copy all of this, and I'll bring this back into Sublime Text so we could call this with removing the double quotes as a string value at the end. I guess this is what? Kind of stage 3 now? Still JScript. And let me turn word wrap on. Obviously, var a is setting a big variable to an array or list of all these integers. And how will it actually execute this at the end? Well, now you can see we're using semicolons as the delimiter for syntax that might be ran and actually evaluated. Let me replace the semicolons with a bunch of semicolons and new lines. And this isn't foolproof, obviously. We are going to end up clobbering what looks like a for loop here, while it didn't have other conditions set in between what would be the starting value for I and then the incrementing I iterator. Well, that's all actually defined with the var syntax in the line above. They include C to be set as an empty string and then I as our iterator value. For the for loop, it ends up adding to that C character list to make a string from the character code at each value of that A array minus 421. Okay, so each of these should end up being an ASCII character, right? Like a letter, number, any printable character. And then it executes this with wscript.shell. The run function here will end up actually executing and invoking as if it were a command typed on the command prompt. So this line is the detonator, right? That'll invoke the next stage and the next payload. But our browser, running this in Brave or Firefox or Chrome, as we're using the developer tools in the console there, it won't really know what to do with an ActiveX object, wscript.shell, because it's meant to be invoked with HTA and CScript and the local JScript rendering. That's fine. We could just make sure we won't copy and evaluate that detonator. Let's just grab this, everything prior and above it. Hopping back over to Brave, right, we could full screen this since I'm basically using this as an interpreter. Let me paste in this value. I'll hit enter. And now we've got some PowerShell syntax carving out. Copy this, make a new document. We can say this is stage 4, removing those double quotes at the end since those were only returned as a string. Stage 4.cmd command that's ran, right? Maybe not .js extension since we're clearly out of that language now, but it looks like we're actually going to be invoking with PowerShell. PowerShell.exe ran as a command, tac W for the window style, set that to hidden, tac EP for the execution policy, set to unrestricted, -NOP NOP, actually no profile. Now the function that gets defined here is going to do what it does, apparently. This is where we could start to clean this. Let me, I don't know, put this chunk in like a stage 4a.ps1, I suppose. Paste that. Word wrap back on. Now again, we could use semicolons as our delimiter. So let's find and replace semicolons. Looks like this function DJOI takes in one argument and then will return the split value of the argument provided, replacing any character ... with, ooh, something interesting, $ampersand to represent the actual value that it's matching on within the replace statement. So ... could match any character, right? So CCEA743D, again, this is hexadecimal, but there's nothing in the way. Now it's just adding the 0x prefix so that it could actually be understood as hexadecimal. They run this on that blob of data we see, JEOLV, and then down below, after that's worked with, they use HAYZDAM set to the value where it is joining together character representations of, ooh, some AES work they're doing here to encrypt or decrypt, as we can see, the create decryptor syntax used for the hexadecimal value here. Probably the key, right? Decrypting AES, the advanced encryption scheme with a given key in bytes, and then decrypting that, forgive me, based off the length of that blob value. Now, where is the detonator? I'm sorry, I keep using that word, but what will invoke now the next stage or the subsequent payload as we're sort of falling down the rabbit hole here? This is what? Stage 5 now? It is simply the ampersand. PowerShell will let you invoke other code to run, another string syntax to be evaluated with just the ampersand preceding, and then it actually takes a substring of the value and gets the rest from the third position onward. So let's try to grab all this and then just let it run safely, smartly, since we know we are not going to evaluate that. What will it do? I can just slap this into PowerShell, and that's a-okay. So maybe bold, maybe brave, but let's get back to the shell that we were in, and let me just paste this in. Defines the function, spits out that blob, and then when I run this, there's no output because it's just being defined in this value. If I actually see what that is, echoing it out, ooh, there's the next little snippet. But you see the first three characters they were working with? IEX, right? IEX is the alias for invoke expression. Once again, basically the equivalent of eval in other languages to run more code. So let's grab this bit. IEX we could probably ignore, but that's why they included that for the ampersand. Back in our text editor, now let's create stage 5. Stage 5.ps1, word wrap on. Ooh, okay, so we start process to invoke a command, in which case that's just PowerShell again, with the window style hidden, argument list being no profile, execution policy being unrestricted. Oh, and the command that's included is this. That does some interesting things because it's all noted with this single quote, but then after the single quote ends, there are functions that are ran here. And because it's wrapping a string with single quotes, the other single quotes that they use kind of need to be transformed to actually make sense in our case. These single quotes are basically acting as double quotes just to define a string, but if we wanted to clean that up and make sure that's actually understandable for us, we probably aren't even going to consider the single quotes and that substring command that's ran from PowerShell prior. Like this would be, I guess in essence, a stage 5a, again, PowerShell script, because this all happens first and before this latter segment here. So let's try and make some sense of this. We could clean up by semicolons once again, and then let's see what all this does. This is really neat because they set up this string, just YP, that doesn't seem to have any other purpose because they use the pipe symbol to say, okay, that value, but then the % sign to say for each. That is an alias in PowerShell for every element in a thing, in which case YP being a string of 2 characters. This will say for each of those, SV which is the alias, if we actually take a look in PowerShell, for set variable. That's going to define a variable. Let's rename this so that's more clear. Defining YP as a variable set to a value of, this is really cool, PowerShell create. And defining a variable multiple times while it's set to the same value basically has no effect. It's still setting that YP to the same thing each time. So there isn't super duper a need for the for each and that YP thing there. I guess that just does it twice, I think, unless I'm not getting that wrong. But now we have YP as a variable accessed with a $ prefix. So inside of another code block here, null is actually set, and that's a reserve value in PowerShell, right? Obviously, if I Control C out, echoing null not being a variable is not going to have any value. Doesn't matter, it's kind of getting thrown in the trash can. We set that equal to YP being a whole new session of PowerShell, which is very cool, right? Pasting that in, it gives you like a subshell PowerShell stream, and they use it to actually find internally, like reaching into its own internals, PowerShell object methods, looking for, in an abstract way, you can see the pipe and where symbol they use, where each element looping through, right, using where to filter $_ for each option that it has, where the name is like *** IP. Now you might have a knee-jerk reaction and think, oh, it's talking about IP addresses, right? Not quite. This is kind of neat. If I were to take a look at the YP new PowerShell methods and objects, if I just dump these all out, okay, there's not a lot. Obviously, YP is not defined. Let's actually set YP to be that. Now I can look at all the things, methods that PowerShell can run and do, but we're looking for the ones that have a name, including IP inside of the name as like a substring. So let me try to grab that. I don't want to invoke it. I'm not going to include the following parentheses that it works with it, but in this case, copying that value and letting that run, it's actually looking for the functions, methods, and things that it can do to add script, in which case it's just adding more PowerShell to run, but not invoke expression, not an ampersand, not all the other neat little eval equivalents, but actually using add script to give it more power. Considering this, it's going to end up executing what it downloads from parent1 gander briskly only.shop with gnosis.mp3. So another MP3 file, right? But is it really an MP3 file? Coolest thing is that they define all this and then actually invoke it. So it's running that PowerShell code in its tiny little subshell, and then they dispose of it. Cleaning that up just a little bit so our curly braces make sense. They're all connected as they should be. So it downloads and executes gnosis.mp3. But after that happens, after it has executed gnosis.mp3, probably since it's invoking it, it's likely PowerShell code. After that happens, set sort of like a comment or a mental thing here, because we don't know yet what gnosis.mp3 will do. But it ends up taking a value for our application data environment variable. Back in PowerShell, that should mean your user's hidden directory for app data roaming. Then it has a function here where it uses curl, the built-in, it's always included in Windows now in modern versions, curl.exe. However, in PowerShell, that is an alias to invoke web request. You would need to strictly use curl.exe to actually run the binary. Those are separate things. Be wary of that. Downloads a location, passed in as an argument, and then saves it to a file with that tac-o output value. Function down below defines another nested function in there that actually evaluates whether or not a path exists. If it doesn't, it uses this download function. We could probably rename that so it makes a little bit more sense. With whatever was actually passed to that, and then its location, but then cleaning up our curly braces, it finally runs this, but the function isn't going to get any arguments there, so I'm not super clear on what that does. But that all happens after code is executed from parent1 gander briskly only.shop gnosis.mp3, right? So we're missing a piece of this puzzle here. We need to go figure out what this is. Let me check. We can get back to Brave, and I actually really like to open a private window with Tor, see if that can connect, so that way, oh, you got a little bit of safety, a little bit of OPSEC, you know, at least you're going over the Onion router, and Brave makes that easy. I should say, back on the email, this link where it was hosting the GoSee song _ada.mp3, the very start of this rabbit hole, I believe is offline. This is just the MP3 file that I had saved previously. This was sent about 2 weeks ago. But now that Tor is connected, let's go see if we could actually hit parent1 ganderbrisklyonly.shop. I think that is also offline. But lucky for us, that was available on VirusTotal, so I can paste it in here. And let me extract this. We'll put it just in this directory. Password is infected by default for typical malware samples. That is usually the standard, and that is the SHA-256 hash. Now let me rename this to what was gnosis.mp3, and let's see if this is an MP3 file or not. Taking a look at the properties, not a lot of metadata here for it other than what we might expect. Let me try and open this in Sublime Text because I am doubtful that that is in fact an MP3 file. Nope, it's not. As we expected, that is PowerShell. Let me save this as what? I guess stage 5B, since it's kind of before the latter end of what we saw for stage 5. This is all invoked before the end of it. Now we've got our syntax highlighting for PowerShell, but take a look at this file. There are about 39,232 lines of code here. And it's a lot of junk, you probably could see. Doing a lot of math, doing a lot of operations, probably just to waste CPU cycles, essentially have this thing sleep in its own right, and a lot of variables that probably don't mean anything. This is where I admit I would be like, okay, I don't want to deal with that. I'm just going to slap it into a sandbox and let it run dynamically to see what it will do for the rest of its payload. So if we were to go down that route, let me just try this thing in AnyRun and see what happens. Now I'm going to upload the zip file so that we could actually extract it as we did previously. I'm going to drop this on the desktop. Password was once again infected. If I rename this to gnosis.ps1, let me invoke it. I'll hit enter on that, and PowerShell will run. I know my face might be in the way for a lot of the process chain, but I don't think we're going to get any love from this. And I'll tell you why. I'll show you why. Obviously taking time to run. Oh, spat out a lot of numbers. I don't know how well you can see those here, but the very end, after we get a lot of these integers displayed, nothing else seems to happen quite yet. Oh, but there was an error. I don't know if you got to see that just in the moment. Let me try to run it in our own PowerShell session, so that way we could see what that error actually is. We'll hit enter on the terminal. Moving into the desktop, and I'm sorry, I know bad resolution here, but let's invoke gnosis.ps1 again, and now we won't have the window disappear. It won't exit out because it's just not that script running. We're still in our own PowerShell session. Spitting out integers. Alrighty, there is our error. Can I zoom in on this? Exception calling invoke with 0 arguments. Operator cannot be applied to operands of type Win32 system info and null. Which makes me wonder, does this malware actually work? Does it even do anything at the end of the day? Because the sample that I've seen even before VirusTotal, because I lost track of it, I got up to this point and then was not sure where to go. Because it's up line 39232, right, at character 135. So I get to the very end here, 39232, set word wrap on. Okay, now it's even harder to look at. Okay, but there's clearly a data dump here. Let me try and figure out what this does, but I think we'll need to use a lot of those variables that have been defined in the sea of nonsense that I don't know exactly what they do. You can catch a very cool little Russian comment here. Figure out what that says. Nothing fancy, just hop into Google Translate, Russian for key. Okay, so likely decrypting with AES, just as we've seen prior. And then it does what looks like an XOR later on. But could we even carve this out? We have a variable that it's going to work with using something as a type, but that's just defined as all of this that uses the other variables that are defined elsewhere repeatedly. Okay, we actually get that set to something. with some of the math, with other variables that are defined. So gosh, it's hard to track that down. We can use AnyRun though, kind of to aid us and see, okay, can we figure out what those values actually are? The ones that are used in this. And let me say this is uncharted territory, so I might have to jump around and skip a lot for video playback, just for me to figure out what even works. Let me try to extract all of the different variables that are used. Let me find all and then use these. I will get the unique values of this, and then we probably don't need the iterators. But now, what will AnyRun tell us is actually happening with these values? Pretty sure I could echo this. Actually, this is equal to that. And if I don't include that, that should be able to display it right just fine, right? Quick context, all I had used was Control-Shift-L to be able to create multiple cursors in Sublime Text. Is this going to run? What's going on? Paste. Do it. Okay. Oh, it's all running from that same content. Dang it. We need to like dot source it. All right, I just restarted the session. Let me run it again, but I want to make sure to dot slash it so that way all the variables will stay in scope for our PowerShell session. Okay, there's our invoke error, and it's on an equals of something. But if I were to paste in all the stuff that we had previously, can I now paste this and see those values? Okay, cool. It's getting some stuff. And all of the things that it had previously. Dang it. All the bytes kind of make that hard to read. Okay, but it is going to create a script block with more stuff. So I think I should echo something into like test.text, and then the very end of each of these, add them to test.text, right? That way we could carve out all the contents and see it for real. Will be a little bit easier to read anyway. Let's try and send that. Or I'm trying it again, but this time I'm using PowerShell commandlets to like add content rather than using the greater than like waka waka append syntax. All right, so the file is too big to extract through AnyRun. So I'm going to see if I can upload the test.text, like all the variable values out to a public site and then pull it down for the virtual machine. Okay, we get our integers and the error, and then if I paste in everything to log the variable values in test.text, now I want to upload these, and I'll use Beamit. Drag and drop your files. Okay, yeah, or click on the parachute. Drag and drop would have been painful. Open this, upload it, please. A79QM. Just beamit.com, A79QM. Oh, dear goodness. You did not get to see because I tried to skip through, but that was a lot of agony. Okay, so now we have all the contents, finally. It is 12 megabytes. You can actually open that in Sublime Text now, get back to home base. Now we can see all of the values. It's using system text encoding, UTF-8, get bytes, get string from base64, and it creates a script block. So what is this one supposed to be? Easiest thing might be to put that in CyberChef, because that way it'll take the ASCII values if they are ASCII values. All right, let me put these side by side and try to make sense of this. The ZN variable, do we see that one again? I think we do. Yeah. So everything that references this as a type, I want to replace with the system text encoding we have on the other side here. Okay, so I think this is like just barely more readable now, where we have the bytes of the string AMSI result not detected, with a big chunk defined up here. That KC variable is the giant blob of values. That is going to be decoded from base64 and then retrieve the bytes out of that. And then they end up getting a script block to execute more PowerShell code. You can see the invoke syntax there at the very end. Sorry, my face is in the way. After they XOR it with the AMSI result not detected string. So could we get that value and then decode that out? What are they doing with the YJN one? That's another big blob just as well. Where's YJN in the mix? Oh no, YJN is that result, decoding that value. So we just need all of these values decoded with the AMSI result not detected XOR. Right? Back in CyberChef, from character code is that, and then XOR Oh, that should be base 10 as well. Sorry. With UTF-8 string, MZ result not detected, right? Paste that in. That's PowerShell code. Let me just download that. I can save the output to a file. Download.dat is fine. Put that there. I guess that's what? Like stage 6 now? Stage 6.ps1? That was agony, but I think we've got the next payload. So we define a couple constants, and it looks like we're doing Win32 API stuff. Let me get word wrap on. Neat that we have an isReadable function to be able to check if the memory protections are in place. Pattern match. If we are using version 2 of PowerShell, then we define an assembly. We build out a couple structs. We get a couple other function delegates to be able to do other Win32 API functions. So get current process, get system info, virtual query, read process memory, write process memory, probably all the plumbing to do some process injection. You can see a classic and cookie cutter AMSI bypass. AMSI scan buffer ends up being built out, and then trying to break it to then eventually get our A defined, which is very, very likely a executable file, tvqqaa. That sticks out like a sore thumb as base64 encoded .exe, or a portable executable file. So yeah, we end up converting that, making that its own assembly, which means it's going to be C#, which means that we can mess with it. So let's carve out that .NET assembly. Let me go to the very top where all those bytes are defined. Let's grab this, and I want to get the syntax here to just write all that. This will be stage 6a.ps1, right? So let's use system IO file, and then I think from there we can use write all bytes. And with that, we can just give it like our stage 7.exe with all of the bytes, right? Yeah. Now I'm okay to run that on my host. In the virtual machine, right, of course. So let's run what is stage 6a, correct? Do it. Oh, yeah, of course. You don't want to run scripts, that's okay. We can set the execution policy to remote signed. You need to do that as administrator. Okay, let's bypass that with stupid EP bypass. Totally malware, right? Stage 6a.ps1. Okay, now we should have our stage 7.exe. Back in Explorer, do we see that? Whoa, it's got a fancy schmancy icon. What is this thing? Mom shared memory sample? What? Original file name ACGPFGT. All right, well, let's get ILSpy or DNSpy or like .peek so we could actually rip that apart. Did Defender delete it? Stage 7 is not there anymore. Oh yeah, it did not like that one. Pure log stealer. I thought I had an exception for that folder. Put it back. I want it. Give me that malware. Okay, so .peek is done installing. Sorry, this is a new VM, so I kind of need to get a tools. And the reason I'm able to open this in .peek is because I recognize this is an assembly, like a managed assembly .NET stuff. So we should be able to rip apart the bytecode. Hopefully it's not obfuscated to hell, but it probably will be. I accept the terms. Yep. That's whatever. Okay, just let me do it. All right, I'm going to open up our MP3 stage 7, named appropriately ACGPFGD. Drilling down into that, we got some other shenanigans. Oh, yeah, it's going to be... I don't know if I want to deal with that. Could DE4. Do it? Yeah, I mean... We could also just run this now in our dynamic sandbox, like any run. And Defender already told us, look, it's probably an info stealer. Oh, it loads another assembly. It's nested even more based off of this. Yeah, the peefcrow little bit here will AES probably decrypt. Yep, crypto scheme, AES create decryptor. So it probably has more nonsense. All right, well, let's take the easy route. Let's just do dynamic. I think even just getting to the executable was still pretty cool. Like that was what, like 7 pages? And it did really sweet stuff. Like the PowerShell add script sort of like reflective thing that it did to be able to determine its own methods. And like even the MSHTA like window on error handler to be able to mask a bunch of other random nonsense code was still pretty cool. Already being tracked as llama stealer, huh? Do be llama stealer. It do be. Steals credentials from web browsers, as expected. Looks like stealing of personal data, as expected. Llama Mutex. Whatever. They went through a lot of work to tuck that one away, though. Connecting to hacknestm.run. And another steamcommunity.com. Wait a second, why? Let me filter for our stage 7 binary. Connecting only to these. So just as we saw, it looks like the first one that was executed then just put together its own process running with its new assembly loaded, right? It ran it a second time. First one detects, hey, this is the stealer. Stealer has been found. There's a little bit of recon. Same sample info data. And then the other one that gets ran, that's where they, okay, immediately detect that's Llama, Bad News Bears. And it's sending it to real Steam. But that's all, like, encrypted, right? That's all HTTPS. I can't really see what that is. I want to know the real URL that they went to. Because they're probably getting that IP address from, like, where it's going to connect stuff back to, from a Steam profile. We've seen that, and they do it all the time. Wait a second. What are these domains that you tried to get to? Awsham.digital. All of this. Stirpicker.digital. We can try and upload our thing now to VirusTotal. Since we got stage 7 finally ripped out, use that one. Okay, no, it's been seen before. Oh, 5 hours ago. Face is in the way. How did they get that? I mean, yeah, that lights up like a Christmas tree. Community notes, everybody's saying, it's bad. LVX Underground got it 2 weeks ago, just when I saw. Huh. What does hacknestm.run look like? Ah. Even through Tor? Bummer. All the DNS requests here, though, pawsham.digital, begindecapher.world, GarageDroots, these are probably, you know, hey, hosted spots otherwise for Llama Stealer and a lot of their infrastructure. So that's at least some indicators of compromise, I suppose. But Info Stealer, you know, another classic cookie cutter stealer. Hey, that's it. That's the end of the video. I don't think I can go particularly too much further. I don't want to deal with a lot of the obfuscated .NET and C#, and from the dynamic analysis and even from the Defender alerts, it's, you know, just another info stealer. Boils down to basically the same stuff we've seen all the time before. But I do really like, my goodness, what, that was like 7 stages just about? I don't know if you count our like A and B little suffix here and there, but look, we had the MSHTA trick. We had that from an MP3 file to start. We had this end up doing that cool little on-error error handler to hide amongst a massive disaster of code. Some PowerShell tricks here and there with that add script and little internal lookup of its own methods and functions. So I thought that was slick. So I hope there were still some cool little breadcrumbs, Easter eggs, couple nuggets that were valuable for you, and good education there. With that said, I'm done rambling. Hey, thanks so much for watching this video. Please do all those YouTube algorithm things, like, comment, subscribe. Please do give some love to our sponsors, link in the video description, and I'll see you in the next video.